So 247 hours on August 6, 1944, Captain Herman Ernst detected a contact on his SCR-720 radar scope at 12,000 feet altitude over Scorton, England. The contact was moving southeast at 220 miles per hour, approximately 5 miles ahead. Ernst was flying a Northrop P-61 Black Widow, the only American aircraft designed from the beginning as a radar-equipped night fighter. His radar operator, Lieutenant Edward Copsall, sat behind him in the raised compartment watching the radar display. The contact appeared as a bright blip on the circular scope moving steadily across the screen. Copsall called out range and bearing continuously. 4 miles, 3 miles. The blip was steady, not maneuvering, maintaining constant altitude and speed. 2 miles. Ernst pushed the throttles forward, closing the distance. The Pratt & Whitney R2800 engines responded instantly, driving the Black Widow to 300 miles per hour. Ernst could see nothing through the windscreen. It was a moonless night, overcast at 8,000 feet, visibility near zero. Without radar, finding the target would be impossible. 1 mile. Copsall refined the bearing. Target bearing, 350 degrees, slightly right, same altitude. Ernst corrected course 5 degrees right. The radar was tracking perfectly, guiding them directly to the target. Half mile. Ernst strained to see forward. Nothing visible yet. The target was there somewhere in the darkness ahead, but invisible to the naked eye. 1,000 feet. Copsall called out, "Visual range. Should see it now." Ernst scanned the darkness. There. A faint silhouette against the clouds, darker than the surrounding sky. A cruciform-shaped wings and tail visible. It was a Heinkel, F-111 bomber, probably returning from a raid over southern England. Ernst closed to 400 feet, positioning the Black Widow directly behind and slightly below the German bomber. The He-111 crew had no idea they were being stalked. German bombers in 1944 had minimal rearward-looking radar warning equipment. They relied on visual lookouts, useless in this darkness. Ernst armed his weapons. The P-61A carried 4 20mm M2 cannon mounted in the belly in a remotely controlled turret. Ernst aimed using a reflector gun sight on the instrument panel slaved to the turret director. The cannons tracked where he looked. At 300 feet range, Ernst opened fire. The 4 20mm cannons fired in synchronization, 100 rounds per minute per gun, 400 rounds per minute total. Tracer rounds every 5th shell showed the stream of fire, converging on the He-111's left engine and wing root. The effect was immediate and catastrophic. 20mm high-explosive incendiary shells ripped through the He-111's wing structure. The left engine exploded, fuel tanks ruptured, fire spread instantly. The bomber rolled left nose, dropping, entering an uncontrolled spin. Ernst broke right, climbing away to avoid debris. He watched the He-111 fall, burning, trailing fire. At 4,000 feet, the bomber exploded, possibly the bomb load detonating. Flaming wreckage scattered across 3 miles of English countryside. Ernst and Copsall circled once, confirming the kill. Copsall noted the position, time, and circumstances in his logbook. Ernst turned west, returning to base at RAF Scorton. The entire engagement from radar contact to confirmed kill had taken 11 minutes. This was the first confirmed victory for the 422nd Night Fighter Squadron in the European theater of operations. It was also validation of everything the Black Widow had been designed to do: detect enemy aircraft in darkness using radar close to visual range without being detected, and destroy them before they could react. The P-61 Black Widow was unlike any other American combat aircraft. It was specifically designed for one mission: night fighting. Every aspect of its design, from the twin-boom configuration to the matte black paint, was optimized for finding and destroying enemy aircraft in darkness. The requirement for such an aircraft emerged from British experience during the 1940-41 Blitz. German bombers attacked British cities at night when British fighters could not find them. Early attempts at night interception failed because pilots could not locate targets in darkness. Visual search was useless. Searchlights were ineffective except in perfect weather. The RAF needed a solution. The solution was airborne radar. British scientists had developed centimetric radar small enough and light enough to be installed in aircraft. The AI Mark IV radar, operational in 1940, could detect aircraft at ranges up to 4 miles. When paired with fighters capable of carrying the equipment, it enabled night interception. The RAF initially used Bristol Beaufighters and de Havilland Mosquitoes as radar-equipped night fighters. Both were conversions of existing designs, not purpose-built night fighters. They worked, but they had compromises. The Beaufighter was slow and unmaneuverable. The Mosquito was fast but lightly armed. In late 1940, the British Purchasing Commission approached American aircraft manufacturers about designing a dedicated night fighter. The specification was detailed: twin engine for reliability and power, multi-crew for radar operation and navigation, heavy armament, high speed, long endurance, and compatibility with British AI radar equipment. Northrop Aircraft Corporation submitted a proposal in December 1940. John K. Northrop, the company's founder, had pioneered unconventional aircraft designs, including flying wings. His proposal for the night fighter was radical but practical. The design featured a central crew, nacelle housing pilot, radar operator, and gunner. 2. Pratt & Whitney R-2800 double Wasp engines were mounted on twin booms extending aft from the wing. Twin vertical stabilizers were mounted at the rear of each boom. The configuration provided excellent visibility forward and upward, critical for visual acquisition after radar guided the aircraft to close range. The Army Air Forces accepted Northrop's proposal on January 11, 1941, and ordered 2 prototypes designated XP-61. The contract specified delivery of the first prototype within 18 months, an aggressive schedule for a completely new aircraft. Northrop's design team worked continuously through 1941, designing and testing components. The aircraft was large for a fighter, with a wingspan of 66 feet and length of 49 feet. Empty weight was 20,965 pounds, maximum takeoff weight 29,700 pounds. These dimensions made it larger than many contemporary bombers. The central nacelle measured 15 feet long and 6 feet wide. The pilot sat forward under a heavily framed canopy, providing 240 degrees of visibility. The radar operator sat behind and above the pilot in a raised compartment with his own separate canopy. The gunner, when carried, sat behind the radar operator, operating a remote-controlled dorsal turret. The engines were Pratt & Whitney R-2800 Curtin double Wasp radials, each producing 2,000 horsepower. These engines drove 4-bladed Curtiss electric propellers, 12 feet in diameter. The engine nacelles extended aft into the twin booms that supported the empennage. Armament consisted of 4 20mm Hispano M2 cannons mounted in a ventral turret beneath the crew nacelle. The turret could traverse 90 degrees and elevate from 15 to plus 75 degrees, allowing the cannons to fire forward, down, or upward. Later production models added a dorsal turret with 450 caliber machine guns for additional firepower. The landing gear was fully retractable, with main gear units retracting into the engine nacelles and the nose gear retracting forward into the nacelle. The gear was hydraulically operated with emergency manual extension capability. The flight controls were conventional ailerons on the outer wing panels, elevators on the horizontal stabilizers, rudders on the twin vertical stabilizers. All control surfaces were fabric-covered and manually operated through cables and pulleys. There were no hydraulic boosters or servo tabs on the early models. The first XP-61 prototype flew on May 26, 1942 at Hawthorne, California. Test pilot Vance Breese reported excellent handling characteristics, responsive controls, and good stability. The aircraft reached 370 miles per hour at 20,000 feet during initial flight tests, meeting design specifications. But there was a serious problem. The aircraft suffered severe tail buffeting at high speeds. The twin vertical stabilizers vibrated violently when airspeed exceeded 350 miles per hour. Engineers traced the problem to airflow separation over the engine nacelles, creating turbulence that struck the stabilizers. The solution required redesigning the engine nacelle fairings and modifying the vertical stabilizer attachment points. This delayed production by 6 months while engineers developed and tested fixes. The modifications worked, eliminating the buffeting and allowing the aircraft to reach its design maximum speed of 366 miles per hour. Production. P-61A aircraft began rolling off the assembly line at Northrop's Hawthorne facility in October 1943. The first 37 aircraft were P-61A-1 models with 420mm cannons but no dorsal turret. Subsequent P-61A-5 and A-10 models added the dorsal turret with 450 caliber machine guns, increasing total firepower to 420mm cannons and 450 caliber machine guns. The critical component of the Black Widow was its radar system. The SCR-720 was an American-built version of the British AI Mark 8 radar. It operated at 3 centimeters wavelength in the microwave frequency band. This allowed a smaller antenna than earlier meter-wavelength radars critical for aircraft installation. The SCR-720 consisted of a transmitter-receiver antenna display unit and power supply. Total weight was 415 pounds. The antenna was mounted in the nose of the aircraft behind a fiberglass radome. The radome was transparent to radar frequencies but protected the antenna from airflow and weather. The antenna rotated continuously, scanning 360 degrees in azimuth and 90 degrees in elevation. The rotation rate was 360 degrees per second, allowing complete coverage of the forward hemisphere. The radar transmitted short pulses 500 times per second and measured the time delay before echoes returned from targets. The display was a planned position indicator showing targets as bright spots on a circular screen. The center of the screen represented the aircraft's position. Range circles marked distances from 5 miles to 500 feet. A bright line rotating around the screen showed the antenna's current pointing direction. When the antenna pointed at a target, an echo appeared on the screen at the target's range and bearing. The radar operator controlled the system from his position behind the pilot. He could adjust transmitter power receiver sensitivity and display brightness. He monitored the display continuously, watching for contacts. When a contact appeared, he would call out bearing and range to the pilot, guiding the aircraft toward the target. The SCR-720's maximum detection range varied with target size and altitude. Against a large bomber at 20,000 feet, detection range was 5 to 6 miles. Against a fighter, 3 to 4 miles. At low altitude, ground clutter reduced detection range to 2 to 3 miles. Minimum range was approximately 300 feet below, which the target was too close for the radar to resolve. The radar operator's job was to interpret the display, distinguish real targets from false returns caused by weather or ground clutter, and guide the pilot to visual acquisition range. This required training and experience. Inexperienced operators often confused clouds, mountains, or electronic interference with actual targets. Training programs for P-61 crews began in March 1944 at Orlando Army Air Base in Florida. Pilot training emphasized instrument flying formation, flying at night, and coordination with the radar operator. Radar operators trained on SCR-720 simulators before flying actual missions. Gunners, when carried, trained on the dorsal turret controls and gun maintenance. The 422nd Night Fighter Squadron was the first P-61 unit deployed to the European theater. The squadron arrived in England in May 1944 with 12 P-61A aircraft and flew its first operational mission on July 3, 1944 from RAF Scorton in Yorkshire. Early missions were frustrating. The squadron flew patrol missions over England and the English Channel searching for German intruder aircraft that attacked Allied airfields and bombers returning from raids over Germany. But German aircraft were scarce in the summer of 1944. Most Luftwaffe units had been withdrawn to defend Germany against the massive daylight bomber offensive. The squadron's first victory, on August 6, 1944, as described earlier, validated the concept. But victories remained rare. Between August and December 1944, the 422nd Night Fighter Squadron destroyed only 7 German aircraft. Other P-61 squadrons in England had similar results. The 425th Night Fighter Squadron destroyed 4 aircraft. The 414th Night Fighter Squadron destroyed 6. The low kill rates had multiple causes. German night operations over England had decreased dramatically by late 1944. The Luftwaffe was focused on defending German cities against RAF Bomber Command and USAAF 8th Air Force. Few German bombers ventured over England after D-Day. When German aircraft did appear, they were often difficult to intercept. German pilots knew British night fighters used radar and employed countermeasures. They flew at extremely low altitude where ground clutter interfered with radar. They used cloud cover to break radar lock. They dropped metallic chaff called window to create false radar returns. The P-61's size and weight limited its maneuverability. At 30,000 pounds loaded, it was far heavier than German night fighters like the Messerschmitt Bf 110 or Junkers Ju 88. In a turning fight, the German aircraft could outturn the Black Widow. P-61 pilots learned to use their superior speed and firepower rather than attempting dogfights. The most successful P-61 missions in Europe targeted V-1 flying bombs. Germany began launching V-1s against London on June 13, 1944, 6 days after D-Day. The V-1 was an unmanned cruise missile powered by a pulse jet engine. It carried a 870-pound warhead and had a range of 150 miles. Germany launched over 10,000 V-1s against England between June and September 1944. The V-1 flew at approximately 400 miles per hour at altitudes between 2,000 and 3,000 feet. It was small, fast, and difficult to intercept. RAF fighters and anti-aircraft guns destroyed most V-1s, but many reached their targets, killing over 6,000 British civilians. P-61 squadrons were assigned V-1 interception duties in July 1944. The Black Widow was ideal for this mission. Its radar could detect the small V-1 at ranges up to 2 miles. Its speed of 366 miles per hour was sufficient to catch the missile. Its 20mm cannons could destroy the V-1 with short bursts. The interception technique was straightforward. Radar operators detected V-1s shortly after launch from sites in occupied France. They guided pilots to visual range, typically 1,000 feet. Pilots closed to 300 to 500 feet and fired. The 20mm shells would detonate the V-1's warhead or disable the pulse jet, sending the missile crashing into the English Channel. The 422nd Night Fighter Squadron destroyed 47 V-1s between July and September 1944. The 425th destroyed 36. The 414th destroyed 29. Total P-61 V-1 kills in Europe exceeded 120, a significant contribution to defending England against the missile attacks. Lieutenant Paul Smith of the 422nd Squadron became the top V-1 killer among P-61 pilots, destroying 11 V-1s between July and August 1944. His technique was to close within 200 feet before firing, ensuring hits despite the small target and limited ammunition. Several times the V-1 exploded so close that his aircraft was damaged by fragments. In the Pacific theater, P-61 squadrons achieved greater success against conventional aircraft. The 6th Night Fighter Squadron deployed to Saipan in June 1944, and began operations against Japanese aircraft attacking American bases in the Marianas. Japanese tactics were different from German tactics. Japanese bombers conducted harassment raids almost every night, bombing airfields, supply dumps, and ship anchorages. These raids were ideal targets for P-61s. Japanese aircraft flew at medium altitude 10,000 to 15,000 feet, made no attempt to evade radar, and had minimal defensive armament. P-61s would orbit near American bases, detect incoming Japanese aircraft on radar at 5 to 6 miles range, intercept before the bombers reached their targets, and destroy them with 20mm cannon fire. The 6th Night Fighter Squadron destroyed 20 Japanese aircraft between June and August 1944. The 548th Night Fighter Squadron, operating from Iwo Jima after its capture in March 1945, destroyed 16 Japanese aircraft. The 549th Squadron destroyed 12. The most successful P-61 pilot in the Pacific was Lieutenant Dale Haberman of the 6th Squadron. He destroyed 5 Japanese bombers between July and September 1944, making him the only P-61 ace. His technique emphasized patience. He would allow the radar operator to guide him within 500 feet before visual acquisition, then close to 200 feet before firing. His shooting was precise, typically destroying targets with 50 to 100 rounds of 20mm ammunition. Production of the P-61 continued through 1945. Northrop built 682 P-61A and P-61B aircraft at the Hawthorne plant. An additional 41 P-61C models with more powerful engines were built but arrived too late for combat service. Total production reached 742 aircraft, including prototypes. The P-61B introduced several improvements over the P-61A. The engines were upgraded to R-2865 models producing 2,100 horsepower each. This increased maximum speed to 370 miles per hour and improved climb rate to 2,500 feet per minute. Additional fuel tanks in the outer wing panels increased fuel capacity from 640 gallons to 170 gallons, extending range from 1,000 miles to 1,350 miles. The P-61B also introduced hardpoints under the wings for external stores. 4 hardpoints could carry 1 600-pound bombs, drop tanks, or rockets. This gave the Black Widow a secondary ground attack capability. Several P-61Bs were modified as night intruders, attacking Japanese ground targets and shipping at night. Some P-61Bs had the dorsal turret removed to save weight and reduce drag. Testing showed the turret created turbulence that reduced maximum speed by 15 miles per hour. Since most combat occurred with forward-firing cannons, the turret was deemed unnecessary. Approximately 250 P-61Bs were built without turrets. Late war variants included the P-61C, with R-2873 engines using turbo superchargers. These engines produced 800 horsepower each, with water methanol injection. Maximum speed increased to 430 miles per hour at 30,000 feet. But the P-61C arrived in July 1945, too late to see combat before Japan surrendered. After the war, P-61s continued serving in various roles. The Air Force, which became independent from the Army in 1947, used P-61s redesignated F-61 as night fighters until 1950, when they were replaced by jet-powered Lockheed F-94 Starfires. Some F-61s were converted to reconnaissance aircraft designated F-15A Reporter, with cameras replacing weapons. The F-15A Reporter served until 1952. Several P-61s were transferred to other air forces. China received 12 P-61Cs in 1946. These aircraft served with the Republic of China Air Force until 1954. The French Air Force received 8 P-61Bs in 1945, using them in Indochina until 1949. One P-61B served a unique peacetime role. In 1948, the California Institute of Technology acquired a demilitarized P-61B and modified it for atmospheric research. The aircraft named Snoopy Prow conducted high-altitude sampling flights collecting air samples for analysis. Snoopy flew research missions until 1955 when it was retired and donated to the Smithsonian Institution. Today, 4 P-61 Black Widows survive. The best preserved example is P-61C, serial number 43830, at the National Museum of the United States Air Force in Dayton, Ohio. This aircraft was never used in combat and retains much of its original equipment, including the SCR-720 radar. It is displayed painted in glossy black, with the markings of the 414th Night Fighter Squadron. Another P-61B serial number 4239445 is under restoration at the Mid-Atlantic Air Museum in Reading, Pennsylvania. This aircraft served with the 548th Night Fighter Squadron on Iwo Jima and is being restored to flying condition, though flight is unlikely given the aircraft's age and rarity. A third P-61 serial number 42394 is displayed at the Beijing Aviation Museum in China. This aircraft was one of 12 transferred to China in 1946 and served with the Nationalist Chinese Air Force until captured by Communist forces in 1949. The fourth survivor is P-61B, serial number 4239403, displayed at the Stephen F. Udvar Hazy Center, part of the Smithsonian National Air and Space Museum in Chantilly, Virginia. This aircraft is the former Snoopy research plane and retains modifications from its scientific research configuration. The P-61 Black Widow's combat record was modest compared to day fighters. P-61s destroyed approximately 127 enemy aircraft and 127 V-1 flying bombs in all theaters. This was far fewer than P-51 Mustangs, 4 950 victories, P-47 Thunderbolts, 3 752 victories, or P-38 Lightnings, 1 700 victories. But the comparison is misleading. Day fighters engaged targets in good visibility with visual acquisition. Night fighters operated in darkness, finding targets only through radar. The operational environment was completely different. Successes were measured differently. A day fighter squadron might encounter dozens of enemy aircraft during a single mission over Germany. A night fighter squadron might fly 20 missions without detecting a single target. When targets were detected and intercepted, it demonstrated successful integration of radar technology, crew, coordination, and tactical skill. The P-61's true contribution was establishing night air superiority over areas where it operated. German intruder raids over England became untenable after P-61s arrived. Japanese harassment raids in the Pacific decreased dramatically when P-61 squadrons deployed to forward bases. Enemy commanders knew their aircraft could be detected and destroyed in darkness and adjusted tactics accordingly. The Black Widow also advanced technology. The SCR-720 radar pioneered many features that became standard on later interceptors. The planned position indicator display was far superior to earlier oscilloscope displays. The integration of radar with fire control systems influenced post-war fighter design. The twin-boom configuration demonstrated that unconventional layouts could provide tactical advantages. Some historians argue the P-61 was unnecessary, that existing types like the Bristol Beaufighter or de Havilland Mosquito could have filled the night fighter role adequately. The RAF certainly achieved success with both types. The Mosquito was faster than the P-61 and by 1944 was shooting down German aircraft at impressive rates. But the P-61 was designed from inception as a radar night fighter. The crew layout with radar operator in a raised position behind the pilot provided better coordination than side-by-side seating in the Beaufighter. The forward-firing armament was more effective than turret-mounted guns. The remote-controlled belly turret allowed precise aiming by the pilot rather than a separate gunner. The P-61 also had superior endurance. With 170 gallons internal fuel capacity, a P-61B could patrol for 4 hours at combat power settings. This was critical in the Pacific, where distances between bases exceeded 1,000 miles. Mosquitoes had 450 gallons internal capacity, limiting patrol time to 2.5 hours. Captain Hermann Ernst, the pilot who scored the 422nd Squadron's first victory, later wrote about the Black Widow's capabilities. The radar gave us eyes in the darkness. We could find aircraft that would have been completely invisible otherwise. The plane handled well, had good speed, and the cannons were deadly. It did exactly what it was designed to do. Lieutenant Edward Kopsel, Ernst's radar operator, emphasized the importance of crew coordination. The pilot couldn't see the target on radar. I couldn't see the target visually until very close range. We had to trust each other completely. I would guide him using radar, he would acquire visually and shoot. If either of us made mistakes, we'd lose the target. This crew coordination was the essence of night fighting in World War II. The technology enabled the mission, but human skill made it successful. Radar operators learned to distinguish real targets from false returns. Pilots learned to trust radar guidance even when they could see nothing ahead. Together, they turned darkness from an advantage for attackers into an advantage for defenders. The P-61 Black Widow represented the culmination of 3 years of development in night fighting technology. It was the only American aircraft designed specifically for this role. It incorporated advanced radar-heavy firepower, long endurance, and reasonable speed in a package that was effective if not exceptional. It dominated the night sky not through spectacular performance, but through methodical competence. It found targets others could not find. It destroyed them efficiently. It gave Allied commanders confidence that night air superiority could be maintained. Northrop P-61 Black Widow. Wingspan 66 feet length, 49 feet. Maximum speed 366 miles per hour. Range 350 miles. Crew 3. The night hunter that turned darkness from concealment into vulnerability. The aircraft that proved radar-directed night fighting could be systematized, trained, and deployed at scale. 127 aircraft destroyed, 127 V-1 missiles destroyed. Countless missions flown in darkness over Europe, the Pacific, and the China-Burma-India theater. The validation of a concept that began with British radar scientists and ended with American industrial production. The Black Widow that hunted when others could not see. The night fighter that dominated the air after dark.